Hey there, logic and truth tables. Continuing on, this is lesson 3.2, compound statements and connectives, and it's actually part 1 of a 2-part lesson. Vocabulary warm-up. A statement is a sentence that's either true or false, but not both simultaneously. The negation of a true statement is a false statement, and the negation of a false statement is a true statement. The negation of statement P is expressed by writing using this symbol right here. We read that as not P, but that is the symbol that we use for the negation of P. Statements that contain the words all, some, and no are called quantified statements. The statement all A are B can be expressed equivalently as there are no A that are not B. The statement some A are B can be expressed equivalently as at least one A that is a B. If some are B's, then there's got to be at least one of them. The statement no A are B's can be expressed equivalently as all A's are not B. The statement some A's are not B can be expressed equivalently as not all A's are B's. The negation of all A's are B, the negation is some A are not B. The negation of some A are B is no A are B. It's either some or it's none. Those are the only two options. Logic and truth tables, compound statements and connectives, part 1. So the learning intentions, the students can express compound statements in symbolic form. We're doing that today. In part 2, we're going to get into expressing symbolic statements with parentheses. And in English, of course, that's going to be using commas instead, but that's another day. Simple statements convey one idea with no connecting words. Here are some examples. I'm leaving, you're staying. Compound statements are formed by combining two or more simple statements. The connectives include and, or, if, and then there's going to be something in between then. So if then, or if and only if. And statements. If P and Q represent two simple statements, then the compound statement P and Q is symbolized by this. That symbol is a mathematical symbol. Looks like an upside down capital V, but it's a mathematical symbol and it stands for and. The compound formed by connecting statements with the word and is called a conjunction, and the symbol for and is the upside down capital V, is what it looks like, but that's the mathematical symbol for and. And statements. Examples. Let P and Q represent the following simple statements. So P is, it is after 5 p.m. Q, they are working. Write each compound statement below in symbolic form. So it is after 5 p.m. That looks like that's the P. And then we have and. So there's our symbol for and. And that last part, they are working, is straight from Q. So this can be represented symbolically using that notation, P and Q. Let's look at B. It is after 5, so that is still P, and we have and again. But look at the next statement. They are not working, so that's the negation of Q. So we have P and not Q, and there's a symbolic form for it. Common English expressions for P and Q. So we have the conjunction there, the same conjunction, but we can use a variety of words. Here are examples. We can, of course, use and, like in the sentence, it is after 5 p.m. and they are working. P, but. It is after 5 p.m., but they are working. Same as and. Yet. It is after 5 p.m., yet they are working. It still means that, hey, they are still there. So that would be and. And nevertheless. So it is after 5 p.m. Nevertheless, they are working. Or statements. There's an exclusive or, which means one or the other, but not both. The inclusive or means one or the other or both. And when we use the connective or, it's going to be the inclusive or. So one or the other or both. That is the one that we're going to be using. The compound statement formed by connecting statements with the word or is called a disjunction. And the symbol for or is this. It looks like a capital V, but it's a mathematical symbol for or. Thus, we can symbolize the compound statement P or Q or both using that symbols. Or statements, example 1, let P and Q represent the following simple statements. P, the bill receives majority approval. Q, the bill becomes law. Write each compound statement below in symbolic form. Let's see what there is. The bill receives majority approval. That looks like P. Or the bill becomes law is exactly Q. So here it is in symbolic form, P or Q. Let's look at part B. The bill receives majority approval. So that is P once again, or the bill does not become law. That's the negation of Q that says the bill becomes law. And there's a symbolic form, P or not Q. Example 2, for or statements. Let P and Q represent the following simple statements. P, you graduate. Q, you satisfy the math requirement. We need to write each compound statement below in symbolic form. So let's see what we got. You graduate, which is P, or, there's our symbol for or. You satisfy the math requirement, which is exactly what Q says. So here it is, that statement in symbolic form, P or Q. Let's look at what B says. You satisfy the math requirement. Okay, so they have Q first, or, ooh, you do not graduate, which is the negation of P. So this is Q or not P for part B. If-then statements, all poets are writers. The set of poets is a subset of the set of writers. We can also express this as there are no poets that are not writers. There is the diagram that shows all poets are writers. And if the person is a poet, then the person is a writer. Another way to write the expression is this statement: if a person is a poet, then the person is a writer. The form of the statement is if P, then Q. If-then statements. The compound statement, if P, then Q, is symbolized by this P and then an arrow to the right, Q, which means implies. So P implies Q. The compound statement formed by connecting statements with if then is called a conditional statement. The symbol for If then is the arrow going to the right. In a conditional statement, the statement before the connective, that arrow, is called the antecedent. The statement after that connective, the arrow, is called the consequent. So antecedent implies consequent. If-then statements, example 1, let P and Q represent the following simple statements. P, a person is a teenager. Q, a person is younger than 20 years old. Write each compound statement below in symbolic form. If a person is a teenager, that is P. Then the person is younger than 20 years. That's Q. So that's just P implies Q. If P, then Q. If a person is younger than 20 years old, that's Q. Then the person is a teenager. That is P. So that is Q implies P, or if Q, then P. If a person's not younger than 20 years, so that's the negation of Q, then the person's not a teenager. So we have the negation of P. So our symbolic form is not Q, implies not P. Example 1 continued. For part D and E, so we have the same statements up there. If a person is not a teenager, so that is the negation of P, then the person is not younger than 20 years. That's the negation of Q. So we have if not P, then not Q, or not P implies not Q. That is the statement in symbolic form. Part E, if a person is younger than 20 years old, so that's Q, then the person is not a teenager, so that's the negation of P. So this is Q implies not P, or if Q, then not P. Common English expressions for the symbolic statement P implies Q. Different words that we can use. If P, then Q. And in our example, for example 1, we had the P of a person is a teenager and the Q, a person is younger than 20 years old. So if a person is a teenager, then the person is younger than 20 years old. Here's another way that it could be used. It could be Q if P. So a person is younger than 20 years old if that person is a teenager. Another way of writing that same implication is P is sufficient for Q. So being a teenager is sufficient for being younger than 20 years old. We could also use the phrase is necessary for. So Q is necessary for P. So being younger than 20 years old is necessary for being a teenager. We could also use the phrase only if. So P only if Q. Contextually, a person is a teenager only if the person is younger than 20 years old. Last one, only if. So only if Q, P. So only if a person is younger than 20 years old is that person a teenager. In a conditional statement, how do I tell the sufficient part from the necessary part? The sufficient condition is a conditional statement, is the part that precedes the arrow, or is the antecedent. The necessary condition of a conditional statement is the part that follows the arrow, or the consequent. So the if part, or the sufficient part, the only if part, or the necessary part. Translating from English to symbolic form, once again, P, this time we suffer huge budget deficits. Q, we eliminate wasteful spending. So write each compound statement below in symbolic form. Eliminating wasteful spending looks like Q. It says is necessary for not suffering huge budget deficits. So this is the necessary part. It goes second. So if we do not suffer huge budget deficits, then we eliminate wasteful spending. That is not P, implies Q. Translating again, P and Q have changed. P is you exercise regularly. Q, you increase your chances of a heart attack. So we are using those two simple statements to create a symbolic form for the statement that's given. So not exercising regularly. So that's the sufficient part, and that is P. It goes first. So not P implies Q is a way to write symbolic form for not exercising regularly is sufficient for increasing your chances of a heart attack. This is the end of Compound Statements and Connectives, Part 1. Thanks for stopping by.